project is to design a wireless charging device for electrical vehicles. Wireless charging device can transmit electrical energy to vehicles on the ground through high-frequency alternating magic fields. It not only reduces the number of batteries in electrical vehicles, but also makes the charging process safer and more efficient. Wireless charging equipment mainly consists of 4 parts: inverter, capacitor, coil, and compensation circuit. For the design of inverter, we use MOSFET and diodes to achieve the conversion for DC to AC power. For the coil, we adopted the DDQ placement mode to increase transmission efficiency. For the compensation circuit, we adopted the LCC connect method. Through this design, we have achieved wireless transmission for electrical energy.
Next, I will introduce the end product description. So first is a zero-level diagram of our project. Our product is a power transmission device based on electromagnetic induction. In the lab, we use DC power supply and measure the output. This picture describes the basic structure of our product. The inverter converts DC current into AC current, which is then connected to the coil through a compensation circuit. The receiving side passes the electric energy through a compensation circuit and a rectifier, and finally delivers it to the battery in the form of DC current. Next is the inverter. To meet the actual needs of our project, we selected IR2110 as the post driver chip of the inverter and controls the opening and closing of the gate driver through a microcontroller. The function of the compensation circuit is to improve the transmission efficiency. According to the characteristics of the original DDQ coil, we selected the LCC circuit for both sides. In this way, energy can be transferred efficiently even if the primary and secondary coils are not exactly opposite each other in the actual application. And the function of the compensation circuit is to improve the transmission efficiency. According to the characteristics of the original DDQ coil, we selected the LCC circuit for both sides. In this way, energy can be transferred efficiently even if the primary and secondary coils are not exactly opposite each other in the actual application.
This part of the coil will be placed on the ground, and this part will be placed on the bottom of the golf cart. When the car reaches the designated parking space, the two coils will be facing each other. At this time, the electric energy will be transmitted from the power source to the electric vehicle battery and complete the wireless charging. By connecting the oscilloscope to the circuit, you can see the working schedule of the wireless component. It provides a DC power supply to the wireless charging system, and the oscilloscope image shows that the inverter has converted the DC input into square wave. Replace the connection point to test the output of secondary coil and compensation circuit. It can be seen that the waveforms are close to sinusoid. At the low side of the system, the current changes back to DC, which can be used to charge the battery, and the output voltage does not change much compared to the input power supply, which means the system has a high efficiency of energy transmission and a low loss.